your desire to learn about the future and feel like what's going on. All right, so this is definitely plugged in. And can we get the slides up? So basically, this talk is going to cover a couple of different things. Really, there we go. Yeah, telcos and the rush for 5G gold. So really what this is about is that over the past number of years, we've been working very heavily and very closely with a lot of telecom companies who have been investing a lot of money in 5G technology. And what they want, eventually, is to get some actual financial and revenue returns off of that investment. And so what the talk is going to cover is where do they think that's going to come from? Why did they invest all this money? And really, what is the future of that sort of 5G landscape look like? At least from the perspective that I've seen it. There's also some giveaways. I have a couple of giveaways. Yeah, so now you're like, I came to this talk, right? And well, you get to choose the one you want, but we'll get there. So for those of you who don't know me, and I think I know most of the people in the room right now, but I'm Evan McGee. I'm the CTO over at SignalWire. We've been doing this kind of stuff since 2017, so working a lot in the CPaaS, UCaaS space. And for 5G itself and for SignalWire as well, it's been a fun 5 years. So for those of you who don't know, 5G was only finalized, the standard, in 2017, right? It's not very long ago. Like, it feels like it's been around forever. We've been talking about it. It's really only been about 5 years. And really, the deployment started in 2018 in China, but 2019 is when they really started to kick themselves off. So we're really sort of new into the 5G landscape. 4G LTE really only finalized in 2009, really kicked off in like 2012. So this stuff has really only been in the last decade. We've had mobile data and the speeds to enable a lot of these cool applications that we get excited about. So if you guys remember, when you're using the old 3G systems, you ever fall back to that, how slow it was, the big leap up to 4G, and then the big leap to 5G. So it's been a fun couple of years of dealing with this, but as our good friends from Telcos and anyone else who plays with 5G can tell you, it's still kind of a wacky, wild world out there. And it gets better and better every day. So again, this is sort of one of the standpoints as of right now. So we're still not all over the world, right? We have the typical North and South America has quite a lot of it. Europe's doing pretty well. But it's a pretty good adoption around the globe, much faster than the 4G LTE adoption was, right? That took almost half a decade to get going. This one only took a couple of years. And in fact, I think that T-Mobile, while initially lying about their 5G launch and what their speeds were, really ended up doing a full launch of 5G across the US in only about 5 or 6 months when they finally got it together. So really an impressive sort of like display over the past couple of years of how quickly this technology is taking off. Oh, that's the wrong one. Whoops, not the Frisbee project. Hold on, that's a bad slide. Anyway, this is supposed to be basically where this is a reused slide from a previous talk, but this is a timeline of when things were standardized, right? We had the first 3GPP right here, first US deployments, and just kind of continued expansion. And we'll get into what camera is and that kind of stuff in a second. But this is the first giveaway point. So for anyone who's here, how much has been spent globally on 5G deployments? You got to get the closest to the number in billions. So just people start shouting. Who's got a number? Who's got a number for me? 48 billion. 100 billion. How much? 20 billion. This is global deployments of 5G. We got 20 billion, 100, 40. How much? 200 billion? 900 billion. 900. Okay, here we go. So the answer here was, who said 200 billion? It's 240 billion. Right? Hey, you're the big winner. So you get to choose here. Do you have kids? Oh, well, then you get to choose either a beautiful scented candle from Los Angeles of various flavors. You have Hollywood, you have Rodeo Drive, or my hometown, Santa Monica, or Goodnight, California. Yeah, that's not going to do for a kid. Your 11-year-old doesn't want this? That's too bad. Well, then, scented candle, Santa Monica, Rodeo, or Hollywood? Rodeo Drive. Oh, man of fashion. I like that. Very nice. All right. You have more chances to win these later. So yeah, 240 billion has been spent globally up to now. 350 billion by 2025, right? So it's quite a lot of money. It's a lot of money they've been putting into this stuff. So really, they are, we talked to a lot of the folks at the top of the telecom firms. They would agree that they're really sort of betting the farm on this transition. They saw the transition from 4G into LTE and what that did for other companies, not themselves. And they thought the transition to 5G is finally where they can earn some money out of these large increases in speeds and data processing and things. And so they really are very, very interested and concerned about how they're going to make back that amount of revenue. And it's interesting, too, that sometimes, somewhere around the world, you have the European 5G sort of trails behind sort of North America and sort of just market penetration. Just geopolitics, things like that, the way things are. It's very homogeneous in the US with only really 3 companies that are offering it. Much more different in Europe in terms of offerings. And China is actually fairly far ahead as well. But really, there's still a lot of room to grow. They're going to be spending a lot more money on 5G deployments. And so where are they going to get this revenue from? Well, here are the potential revenue sources they're looking at, right? So what they really want to do, and this is a fun chart that I found from PwC Analysis, that gives you a good sense of sort of where their head is at. Now, what are telcos good at? Right? They're really good at this stuff up here. All of these standards rollout, all the technical stuff of migration, Open RAN. This is things that they're very confident building out. As you move down here into the services, and as you see down here in actually the monetization category, where they have no idea what to do, things get a lot more complex. Well, look, fixed wireless access, that seems to be a fairly easy thing for them to understand, right? They understand how to do that. It's right in their wheelhouse. Everything else is just like some challenges, many challenges, and I love how the whole monetization part is many challenges. They do not understand new services revenue. They don't understand how to get financial metrics out of it. All they know how to do is deploy it. And what they hoped was they would deploy 5G, and then suddenly, magically, it would happen. Like, people would use it. You'd be consuming gigabytes of data a day, and just they talk about it like it was an inevitability, when in fact it wasn't. And the reason it wasn't, I think this might be the one. Well, for a minute, let's focus on that little lower part there. I'll get into the reason it wasn't in a second. We'll focus on the lower section of what is that new services revenue. So these are the kind of guys they talk about, right? I threw up SignalWire because that's who we are, but that could be any other CPaaS or UCaaS player that's out there. You have WhatsApp, because that constantly comes up when they talk about losing messaging revenue and SMS, which when you get into 10 DLC and all the things in the US, when you're getting into kind of trying to squeeze the blood out of the life of SMS, right? Trying to charge fees. It's because they're terrified of WhatsApp or anything else like that. And then you have AWS, right? They were like, listen, we're telco providers. We can also provide cloud hyperservices and hyperscaling infrastructure. Well, they realized pretty fast that actually that's not the case. So now they're just partnering with these guys. They tried releasing their own cloud solutions, and they stunk at it. And so now they're partnering with AWS and Google to release edge cloud deployments. They still have their data centers, but now they're just powered by AWS or Google, which actually makes life as a developer a lot easier, and hopefully will get them some additional revenue as well. But again, the idea is they need to have applications that require living on the edge. That requires use cases, and they keep talking about IoT, real-time, real-time driving, automation, VR, AR, gaming. They're really hunting for use cases that have not quite materialized yet, to be honest. And so they're focusing on other revenue streams. Like I said, WhatsApp, the revenue stream there really is they're trying to. Their version of that is, well, we don't know how to do IP messaging that well, so we'll just charge a lot of fees for SMSs. And we also, in the US at least, they don't want to be regulated, right? There's a terrible fear of regulation. So they've invented things like the TCR, the campaign registry. And the campaign registry's entire life is basically be the ticket master of SMS, right? They're there to be hated so that the telcos can extract more money of that industry before it eventually goes away. And they are fine with that, and that is kind of how it works. And they just really want to avoid the government coming in and saying, you have not done anything to clean up spam or whatever. So we can talk about the TCR for a while. If you're into messaging, come find me later about that. What they really want to do is do a telco for developers. So a lot of them are trying to move into the CPaaS space, right? You can see they like the revenue growth here. You can see that little bit of a hockey stick. You go from $7 billion to $25 billion here in 2025. They see increases, particularly over COVID, in video and chat and any kind of messaging systems. They see decreases in actual legacy communications. So they're excited about the revenue opportunities, potentials in CPaaS and other value-added services. The problem is they don't really know how to do it. They've tried, and I'm sure a lot of you potentially have dealt with telcos who have attempted to run CPaaS services themselves in the past. I know everyone, this is the same refrain we've been talking about for like a decade. They've been trying this stuff for even longer than that. Many failed initiatives to try to get this moving forward. Well, they still want it, right? And they want it now in specific contexts, like data sovereign contexts, where it has to stay only in Germany, or only in Switzerland, or only in Israel. These are very specific things that are appearing now where the legislation itself says that communications has to stay in country. So data sovereignty is becoming a very, very hot button item as well, which actually gives them more of an opportunity because those firms tend to be very nation-centric a lot of the time. So they have an opportunity then to actually engage at that level. They also have tried a bunch of different initiatives, right? They've tried things like Open API. If you guys knew what this one was, this was an initiative, right? Back in 2016, they launched this, being like, great, we're all going to come together and form one unified API set that developers can use. And it just blew. It just never worked, right? The adoption, you had a lot of companies up there, a lot of great logos that could have brought this together. But they never really came out with a coherent set of any kind of standards. They kind of got lost in committees. They never actually put anything into the real world that was unified. No one jumped on board. They were scared of the scaling aspects. They were scared of how to actually take it to market. They had no real developer willpower or need. And that's kind of the thing, right? You can't just will a developer community into existing. They're hoping they could, by its virtue of having maybe some API specs out, people would show up and just build it for them, or they could all work together. But they had no real incentive to work together. So they thought to themselves, well, you can't just will one into existence, right? Don't tell me what to do. So they're doing it again. So they're doing it again with Kamara. So Kamara, the global, it's the same. A few more logos. Got a bunch more logos up here, maybe twice as many logos. 2021. It's basically the exact same initiative a bunch of years later. The biggest difference between this one and the previous one is this one actually does have an API spec, and at least for Kamara, however you want to pronounce it, they are focusing on network-level APIs, exposing, what that means is exposing things like the location data from your phone, right? You can get the GPS dips as an API. They're trying to standardize that simple stuff. What they're not doing is going up or sideways of the stack at all. They're really just taking the things that they bought from Ericsson or Lucent or anybody else and trying to expose them as external APIs and paying a lot for it. So this might turn into something you can use, but it's not going to be something you're going to go to like a Deutsche Telekom or a T-Mobile probably directly to grab. You might, but most likely what you're going to do is have to go through some sort of aggregation layer. So they're going to require a partner to do this, because again, they're not structurally aligned to provide these services to developers, right? That's just not how those companies work. So they're going to have to work with an aggregator or something like that who is much more web-focused, can build SDKs for people, is much more comfortable working at the speed of the way the web changes, can deal with WebRTC interop, all that kind of good stuff. If they have a unified sort of Kamara open API for the network functions, then you can actually have a nice unified, if I'm trying to do an anti-fraud solution that uses your location and you're on Voda versus, again, T-Mobile or DT, that would be a nice system because it makes the developer experience a lot more fluid. But it needs the kind of interop between those companies to do that. We'll see if that actually helps. What they can do, and what they're really good at, is having big sales teams and customer success teams, right? They can get out there and they can pitch these to mid-market and enterprise customers, and they can lock those down. They lock down to multi-year contracts. They're really good at that. And those are very, very sticky. People don't get fired for buying Deutsche Telekom. They get fired for buying some fly-of-the-night, little tech startup that ends up failing. So these are incredibly important metrics that they can bring to the table, combined with partners that understand how to get the services out there. I'll use SignalWire as another example here, where all these guys over here, they can bring all those systems, bring it through the telco infrastructure into a person like SignalWire or a place, who then provides the web-style APIs that then connect to all the services that they want to connect to, right? You have any AI systems or TTS or ASR, anything from Banafo all the way through, any kind of service you might want to do. This is something that people from the web can show up and, SignalWire can focus on things like documentation, SDK, stuff like that, and the telcos can worry about providing the underlying physical network connectivity and only things that they can provide, such as the APIs for network slicing, stuff like that. And speaking of that, one of the other things that they're really interested in on the network side is how do they do things like network slicing or private 5G networks? And who here knows what network slicing actually is? Raise your hand if you've heard of it or kind of vaguely know it. Yeah, okay, so only a few people, right? So network slicing effectively is the idea that you are taking a section of 5G spectrum and bandwidth and basically allocating it to a certain business function, right? So you can give it to, you can take it and give it to an IoT function to make sure the little robots can move around. You can do it at ball games. They do it in the US quite often at stadiums, I think, right, James? That's potentially the case. This is the sort of the market forecast of that, where they really feel like that's going to kind of take off for private networks at least. 5G private networks, right, or just kind of a 5G network that they kind of give to whoever needs it. Again, pretty large organizations here. We're talking, utilities, oil, gas, mining, manufacturing. These are not consumer level. These are big verticals that need private networks for various purposes, whether they're disconnected from the grid or they have very unique networking situations or security circumstances. But again, look at the amount of money there we're talking. We're talking, $4 billion. By 2025, you're about up to, what is that, $16, $17 billion maybe for all private 5G networks. Okay, that's not so bad. You have the network slicing here, right? So this is interesting. These are, a lot of players are trying to get this out there. They offer these services to the telcos quite a lot. It kind of, a little bit of analysis. But again, look at I wanted to point out here in the corner, the CAGR of that is only 51%. You go from about 244 million today to about 6.8 billion by 2029. It's not vast. This stuff is not predicted to grow that quickly. And again, this goes back to the problem of they're trying to find where the revenue is in 5G. They've dumped, are going to dump 350 billion into this. So where are they going to get the money back from? So they're awaiting that 5G killer app. And if we go back and say, wait, what was the 4G killer app? So here, I'm going to give another giveaway here. What was the 4G killer app? FaceTime. What else? YouTube. Netflix? Anybody else? TikTok. I wish it were TikTok. Yeah, what's that? Voice over LTE. So, Tim, I think you're going to win on that one. Because basically, the answer was just the iPhone in general, right? The answer was the iPhone was the killer app. And so what would you like, Tim? Would you like a candle or a book? Huh? Candle. You want Santa Monica or Hollywood? Yeah, Santa Monica. Yeah, you do. There you go. It's the best smelling one. So the greatest trick Apple ever pulled was convincing the world the iPhone should cost $200, right? That was when it first came out, and it was eventually first came out, it was like $800, but then it instantly subsidized, right? And so what did that do? That basically showed the people that, you now have a mobile computer that can consume data very, very quickly. And if you remember, there was only 3G when it came out, but very soon the LTE stuff started to come out. And the 3G... Right, it was only 2G when it came out, right? The original was 2G. It was the 3GS was the 3G. And that was where it got really popular. And then iPhone 5 is when it finally got LTE. But the adoption of those, as you'll see here in a second, I got one more giveaway to do first. So again, the reason why, and I'm actually going to go forward one and we'll come back. I can't. You're going to ruin this one. I didn't do the animation right. Anyway, so another quick giveaway. What is Apple's total market capitalization as of today? Quick guess. 1.2 trillion. How much? A trillion? 1.2 trillion? 0.9 trillion? Well, too late. 2.9 trillion. It's almost $3 trillion company as of today. How? It's crazy. Book or candle? Candle. You, my friend, get Hollywood. All right. So $3 trillion company as of today. And what is that on the back of? You guessed it. It's all iPhone sales, right? These are, check this out. Let's get these things up there. So first year, it was $650 million when they released it, right? The next year, it was already $6 billion. So we're already more than network slicing in year one of releasing an iPhone, right? And over here, we get up to $50 billion. By the time LTE hits in 2012, we're almost up to like $70 or $80 billion just selling iPhones for Apple. Like, this is the killer app that they saw. This is what the telcos saw back in the 4G revolution. They were like, we want that. We want that kind of revenue curve. But what they don't understand, and they saw all this money going to Apple. They're like, great, so Apple's winning this war. They were getting long-term subsidized contracts for multiple years, at least in the US, and that was great. They had plenty of time for that, lots of stuff, fun earning those contracts. But they saw Apple really earning all this money. And there was a core belief that was because the network speeds were getting faster and faster. That's what made the App Store work. And to their credit, they were right. With 4G and LTE coming out, that's what made a lot of the apps we use today very, very usable. If you remember using a lot of the maps and things, even when the 3G was out, it was a little bit slower. Really, the network speeds is what made that experience what it is today and kept that curve going, which is why you started to see large jumps. This was the 5. The 5 form factor was much better form factor anyway. That was that jump. But these jumps to here were just increases in people buying. And this doesn't include any Android devices, right? I know around the world there's a big push. The US also, I like to point out, is so iPhone heavy because of those subsidies to the phones. It's why we were just talking to some colleagues from Brazil, and they were shocked that in the US, iMessage is such a dominant messaging platform, whereas around the world, really, it's WhatsApp. And the answer is because anyone who has an iPhone, they've just made it really easy. If you have an iPhone, you don't need to use WhatsApp with other people who have iPhones. The US market penetration of an iPhone is about 50-something%. In Brazil, I think it's about 20%. And that was, early on, too, was a lot of America. The rest of the world really lagged behind in iPhones. Even Europe now, which has, I think, above 30% iPhone penetration, that's very recent compared to Android. That's why WhatsApp dominated the world, whereas iMessage really kind of dominates inside the US, unless you have an Android device. So we have that. So they want to know, the telcos want to know what is the next thing that's going to drive that data consumption of 5G systems. How can they get in there? What's going to be that? And they've had a bunch of ideas over time, right? One of their biggest ideas is that VR and AR are going to do it. They've been talking about that forever. They were like, oh, the VR, the metaverse is what's going to drive. Everyone's going to be walking around just consuming endless data from their pockets, somehow paying for it. They've thought that was the dream app for a long time. And we all know now that that has not worked out. It's not the way that it is. As much as we would love to have that be good, we'll see next year if $3,500 is something people are willing to pay for this. But again, are you going to buy more mobile data service to use this? Probably not. You're not going to walk around in public wearing these headsets. You're going to be using it at home with your Wi-Fi, right? And they're not able to charge you more for the data, right? We have proven as just sort of a consumer base that we're willing to pay our amount for a data wireless plan, but they can't charge us more for 5G data versus 4G. It's all the same. So this could represent a giant opportunity, right? If this product platform takes off in the same kind of growth curve that the iPhone did, it's quite possible they could consume a lot more, but we're not going to know for probably 7 to 10 years whether or not that's actually going to work out. And I threw this in today because I hope hopefully in the future it'll be powered by Matrix. So if you guys were here for the third room, that would be great. IoT was the other one, right? IoT was going to be the killer app for 5G, right? The fact that you can have higher densities. In fact, you could have more devices out there. And it is real. There are a lot of IoT applications out there. But right now, even at least the US market for that's only about $4 billion today. Going up to 20 by 2030, but still not enough, right? These are small incremental bits of revenue that they're getting every year, but it's spread across multiple firms. They can't really isolate it. The IoT really comes down to sort of industrial automation tasks and vehicles, sort of remote things like that. But there's been no sort of like broad adoption of 5G IoT, and it might also because the hardware is not particularly ready yet. There are others here who can speak more directly to that. They want this to be bigger, but it is what it is. So could AI be one of the killer apps here? So this one kind of came up recently, right? This is not something that was on their radar until recently. And why could AI be one of them? Well, AI could be one of them because it is so computationally heavy, you can't do a lot of it on device, right? You have to reach out to the internet to handle a lot of this stuff. So you could, it also brings up the sort of new paradigm in sort of human-computer interaction where if I'm talking to something and dictating to it, or if I'm trying to, type in any of the new LLM stuff, you have to then send that off to the cloud to do something. And because that requires constant connectivity, it actually does drive more data usage, which is everything they want to see. So as this is built into more tools, whether or not they could run on the phone or not, it could be that this actually does have that increase in data consumption they're looking for, which they might be able to monetize. And I do love the way that this is turning out, right? I'm a huge fan. I've been following AI for quite a long time. You've seen other talks in the past. I've talked a lot about this stuff. I feel like the way that we're going to work with this is sort of the way they did in Star Trek, The Next Generation. Who here is the Next Generation fan? Yeah, right? So remember when they walk into the holodeck and just command it to do stuff? This is one of my favorite scenes from it, so you can just watch this for a sec. Oh, you can't really hear it. Okay. Yes. So, okay. Oh, you can't hear it. You can't really hear it. Anyway, damn it. Anyway, that's Barkley. He's running down the thing. He basically is telling them, I'm surprised you can't hear that. Anyway, so he says here, I'll slide it forward. He walks in, he's like, create workstation chair. And he creates the workstation chair, right? And he goes, create a console for the right hand or left hand. Boom, right there. Right hand. Boom, right there. He asks it to build a neural link interface. The computer says, sorry, no record of that is found. And he goes, no problem. Here's how you build it. And kind of goes forward from there. That idea of just being able to talk to the environment, have it construct the things that you need, right? There's many examples in that show of doing it. And they used it in Star Trek, and this is actually a thing I talk about a lot of why I think Star Trek is interesting, is because they used it to forward the plot. The whole point of Star Trek was not to get hung up on the technology. It was to make the human story advance faster. That's why they invented transporters, right? They didn't have enough screen time to get people constantly into a shuttlecraft and get them on and off of it and just take too much time. So they're like, great, we'll just beam you back and forth. Why were the computers sort of hidden in the walls? If you remember from Star Trek, the Wrath of Khan, where basically like Leonard Nimoy, Spock goes to, he has to save the Enterprise. All he has to do is move like a glowing rod from like this container to like this container, and like that's it. It's like this far apart. And just doing that, he dies. It like kills him to do that, literally. But that's all it was. The point wasn't he has to, watch the newer Star Treks, and they're swinging around engine rooms, and they're humongous, they're like climbing stuff and being all gymnasticy. That wasn't the point. The point was that a person was sacrificing themselves for other people to get something simple done. So as the technology sort of blends into the background, it enables these more human stories to come about. And I think that what we've seen with the newer AI stuff is that exact phenomenon happening. People are like, oh, I can make my life easier and better and faster using these tools. And they let me, as a person, move more quickly and allow me to live my life and do things that I want to do rather than get stuck being forced to do what the computer system wants me to do, which some of us love doing, but many people just want to get it out of their way and move on with their lives and keep living. There were kind of 3 generations of computing in that regard. 45, sort of the batch processing, right? Everything was kind of loaded in via the papers, and you kind of just had maybe run overnight and you get a result in the morning. Then in 64, you really had to switch to command-based processing, where you could actually just do interactive and interrogative stuff with the computer. And so now we're getting to new stuff, which is really just intent-based processing. You tell it what you think you might want it to do. I want I told it this one, right? So I was like, I want some pictures of telecom developers discussing the secret details of 5G, right? Or I want this one. We're all at a manor house in England on a gorgeous summer evening, informal, playing lawn games, drinking a cocktail, which I'd also like to point out completely also fails the Bechdel test, because there's never any women in these photos. If anybody, it has learned that when you put engineer, it should be all men, which is in and of itself a commentary on society that we need to fix. But these are the kind of things that you could sit there and say, okay, I type this stuff into my phone, or I'm talking to it. Now imagine these are movies or some sort of game you're playing that's generative in that regard. And these are being generated sort of server-side, cloud-side. That might run over cellular. That might drive some sort of 5G data adoption. That could also need to run on the edge because it needs to be faster. This is actually a use case that's emerging now that could potentially provide some sort of that giant revenue boost, although we don't really know what it might be yet. You also have sort of these low-code AI tools, right? You have these sort of things here are, IVR systems using AI to walk them through them. Typical sort of AI use case stuff. Again, this kind of feeds back into the whole CPaaS level. And that's sort of it for me right now, right? What I kind of wanted to get across at the end of the talk here was that where we are in the adoption of 5G is very, very early, right? We're incredibly early on in the journey of this. They didn't really, I would say, jump the gun on deploying it, but the revenue and the potential to extract business from that has not yet arrived. So I would say that if you're working with 5G systems, or if you're interested in that ecosystem at all, it's still basically a giant greenfield. There is endless opportunity there to develop something that would be useful. There's a lot of hunger for applications and things that will use this technology or that can interface with it well. So I would say keep your eyes peeled, keep your ears to the ground for things that could actually make an impact in that world, because they are desperate to find things, and it's going to be here for a while. You're not going to see a jump to 6G here very quickly, and if you do, it's going to be a marketing jump. There's going to be no real fundamental technology jump for at least another decade. So this is what we got. This is what we're going to live with. It's going to get better. It's going to get faster, but the technology itself, if you're working with any kind of those systems, you're good to go for a little while. So thank you all. I appreciate it.
Thank you, thank you. We do have a few minutes in which you might want to ask Evan some questions. He's come all the way from America, so we should take advantage of that.
I also have a book. If anyone has any little kids, here's a little book, Good Night, California. Yeah?
There's a hand at the back. Come along, sir.
You got it.
Come and get your little prize. That's right, Mira. He should have a round of applause for asking. My pleasure. You can improve your chances of getting what you want by asking for it in life. Okay, who's got a question for Evan?
Or a general conversation with the topic. I know people in here are experts on this field, so I feel like I'm talking to the crew who knows.
Well, I already made a correlation in my head that James Bodie has been asking people about applications to go on the back end of 5G. Actually, Nitzin has got his hand up there. Let me bring the mic over, and then you can... we got a roving mic. Thank you.
That's my job on the OpenSIP Summit. Thank you. Much appreciated. So, coming from the States and looking at the global market and comparing from Europe to United States, when it comes to deploying the 5G, why do you think that, what do you think would need to happen in Europe for it to progress faster and to be implemented wider?
I think the holdups in Europe, and this is, again, I'm primarily focused on North America because that's where I'm based. The holdups in Europe, from what I've seen, are primarily based on intergovernmental, like intragovernmental things, like regulatory holdups in various countries for whatever reasons, whether it's cell density reasons, whether it's regulatory sort of lockdown. It depends on country by country. Whereas the US being one giant country, our problem there is that if you're going to roll out a 5G network in the United States, it has to be, people expect it to be everywhere. And the country is so damn big that you really have to get a lot of it before you can call it done. You can't just have it be in San Francisco or LA and New York. It has to be everywhere. And so that's our problem in the US, is that when you do it, it has to be really, really big. Here you can have pockets and it can work a little better, particularly if you can fall back. And it's also one of the reasons why data hasn't, I don't know, it's one of the reasons why I think that you haven't seen applications that necessarily need to consume that much data that quickly, because you do run into pockets still, even anywhere, of 4G LTE, and as you transition those, right, the quality of service changes. You can hear it, on VoIP drops. All kinds of stuff can happen. So until everything is blanketed with the new thing everywhere, I think you're going to see some more friction in that regard. But primarily, it's just because of the number of countries in Europe and they have different laws.
Thanks.
Do you feel your question was answered then?
Yes.
Good. Okay. Jared had his hand up near the front. Here he is. Can you put your hand up again, Jared? And the gentleman will bring you the mic.
Good.
There you go.
I know there's a lot of talk with the telcos and edge computing, and how much of that is them wanting to use edge computing for their own network build-outs, and how much of that is, do you think they're trying to expose that edge computing to potential customers?
So they're trying to do both at the same time. They want to use it themselves, and they have all that extra capacity. They're like, we have lots of capacity, let's give it away. A good example is AWS Wavelength is their version of that for Verizon. The downside is, if you go look at it, they have blocked all UDP in and out and all kinds of other weird stuff. So for our use cases for telecom, it's extraordinarily difficult. We've put stuff in there and leveraged that a little bit. And then you talk to people and say, hey, well, why, what's the use case for this, right? One good example we had was autonomous driving. For every 10 milliseconds was an extra 5 or 10 feet of stopping distance for people we were talking to who were doing, literally people with remote driving trucks. So they were like, if we could have video, and they wanted to basically have cameras in the cars and then someone driving it remotely, so having any kind of video hairpin inside the edge infrastructure for them made sense. But that was one of a few use cases. We tried to help them think of ideas around gaming or anything else that could really accelerate. I mean, that was one of the reasons Subspace collapsed, right? Is because Amazon gave away Global Accelerator, but then it turned out the internet's probably good enough for 95% of the use cases. So there's no locking fit there. And so that's why they desperately want to find something that needs that capacity. And it might be that some of these newer AI tools will use that, if they can put some of the GPUs to the edge, but it remains to be seen.
Thank you, Jared, and thank you, Evan.
My pleasure.
Now, if you've got more questions, Evan is going to be knocking around at the conference. You can go up to him and talk to him in real life. But let's give him a big ComCon thank you for being here. I can already see our next speaker has got his little bag of goodies out, which is exciting. Tim's going to be taking to the stage, Tim Panton, with a talk all about getting the most out of small hardware encoders in mobile sources. So we're just going to take a minute to get that set up, and then we'll be starting that very talk in just a few moments.